Hello, and welcome to Wireshark Certified Network Analyst video course. Today, I will introduce you to the world of network analysis, and we will cover the following objectives. First of all, we will define the network analysis. Then we will see which tasks are appropriate for a network analyst professional. After this, we will discuss the general traffic flow in a network. And the last task for the day will be how to avoid the needle in the haystack issue, when you have a lot of packets and you don't know where to start to solve your problem. So let's go. Network analysis, also called protocol analysis or just sniffing, is the process of listening to and analyzing traffic. It offers you an insight into network communications to identify performance problems, analyze applications behavior, or perform capacity planning. Network analysis is not a rocket science. Anyone can analyze network communications. However, you require some skills to be a good network analyst, and those are a good understanding of TCP/IP communications, comfort using Wireshark, and familiarity with packet structures and packet flows. You need to understand how networking devices and protocols work, how the clients find the IP address of the host if they browse to google.com, what happens if the local domain name server doesn't have its IP address, and so on. Network analyzers tools are called sniffers and can be either software or hardware plus software solutions. So, how does the process of network analysis look like? It consists of 3 stages. Capture packets at the appropriate location, apply filters to focus on traffic of interest, and review and identify anomalies in the traffic. Now, how many times has this happened to you? You're working on an important project and you need urgently to download a file from a web server. You press the link and nothing happens. You turn back to your Word editor, correct some mistakes, and check the browser again. The file still didn't open. You click nervously the link 10 more times and wonder, why the hell did the file not be downloaded? If you had a Wireshark in your background, you would easily find the answer before getting nervous. So, what tasks can be performed by a network analyst? They can be divided into 4 groups. Troubleshooting tasks, which include locating misconfigured and faulty devices, identifying network delays, packet losses, and others. Security tasks, like identification of malicious traffic, unencrypted data, network forensics, passively discovering other hosts. Optimization tasks, which include but aren't limited to analyzing bandwidth usage, evaluating applications efficiency, or evaluating response times. And application analysis tasks, for example, analyzing bandwidth requirements for an application or identifying protocols and ports in use. To avoid legal issues, you should capture traffic just if you own this network or you have written permission to sniff traffic on this network. Consult a legal specialist to understand your local laws about wired and wireless sniffing. For example, prior to January 2011, in Syria, Sudan, Libya, Cuba, Iran, and North Korea, even to download Wireshark was forbidden by law. Before we start talking about the general network traffic flow, I want to talk to you about 2 important notions in Wireshark: packets and frames. If you took other certifications before, in Wireshark those definitions can be confusing. Let's take, for example, an HTTP request. At the server's NIC, it will come in the following form: the TCP header plus the HTTP, and it's called a segment. The IP header plus the segment is called a packet. An Ethernet header plus the packet plus the trailer is called a frame. In Wireshark, they're interpreted a little bit different. The Ethernet preamble, starter frame delimiter, cannot be captured because the capturing starts right after the starter frame field comes. The checksum is missing because the network interface card drops all the frames with wrong frame check sequence, but the right ones are stripped off. In addition, a frame layer is added as a header to all the data which remain from the Ethernet frame. It contains general metadata about this data unit. The whole data unit, which we have right now, is called a packet. You will often see Wireshark menus which contain the word packet in it, even if it is applied to any layer 2 PDU, without any IP header. Now, let's talk about the network traffic flows. First of all, let's briefly analyze how a switch works. Before forwarding the packet, the switch checks whether the source MAC address is already recorded in the MAC address table. If it's not, the switch writes the interface from which the frame came from and the source MAC address in its MAC table. Next, the switch looks at the destination MAC address. If it's a broadcast, it's sent to all other connect ports. The same is done for multicast addresses if it's not configured otherwise, and if it's a unicast address, the switch looks up its MAC table and sends it just to the right port if it's known. But if the MAC address isn't found, the switch acts as if it was a broadcast frame. Also, switches drop all packets with incorrect checksums. Now let's take this small network as an example. We have a server and a client, 2 switches, 2 routers, from which one implements NAT. In the first step, the client generates a frame with the IP address of the server and the MAC address of the default gateway as destination, which is router 1 in our case. MAC addresses are composed of 6 pairs of 2 hexadecimal digits, but for simplicity, we will just use the last pair in our example. The switch doesn't change the frame contents by default, so both MAC and IP headers remain the same after leaving the switch. Upon receipt, the router strips the Ethernet header and consults its routing table. If it doesn't know where to send the packet, it'll be dropped. If a record is found, the router appends a new Ethernet header and sends a frame to the next router. Also, the time to live value is decremented. If it reaches 0, the frame will be dropped. When the next router with NAT enabled receives the packets, it processes in the same way the previous router did, except that the source IP address is changed to the one outside the NAT. The second switch doesn't alter the traffic as well, so the Ethernet and IP addresses will remain the same after leaving the switch.
There are also other
networking devices which modify the traffic. Network firewalls can support NAT and PAT technologies. Proxy servers also modify the traffic as well, but it creates another connection to the destination host. So when analyzing traffic at the proxy, you need to analyze 2 separate communications. VLAN technologies add a VLAN tag to the Ethernet header. They're used in switched environments to create virtual connections. MPLS, which stands for multi-protocol label switching, also can add an additional MPLS header to the frame, which is stripped off when the packet leaves the MPLS network. Most of the smart infrastructure devices can alter the traffic as well. So the best way to know how those technologies affect your traffic is to capture packets before and after they enter the device. Many times, new analysts capture thousands of packets and they are faced with the needle in the haystack issue. They feel as they're drowning in packets. To avoid such situations, you should place the analyzer appropriately, not to capture unnecessary traffic. Apply capture filters to reduce the number of captured packets as well. You can also use display filters to focus on specific types of traffic. You can colorize conversations to highlight traffic of interest. You can reassemble TCP, UDP, and SSL streams for clear view of exchanged data. You can save subsets of traffic to analyze them separately. And you can also build graphs to detect patterns in specific traffic. All these techniques will be analyzed in the next chapters. Today, we've learned the definition of network analysis. We saw some of the most important tasks which can be performed with Wireshark. And we analyzed the general network flow through switches, routers, and other devices which can alter the traffic. The last thing we've learned are techniques which we can apply to avoid the needle in the haystack issue. That's all for today. Thanks for watching, and see you next time. Bye.